Hi guys, my name is Stephen, and on behalf of my entire legal team, Carl and Maddie, and my visiting director, my sister, who's out here from Lancaster, Pennsylvania, I'd like to welcome you back to my calibration channel. I have over 30 years experience working in facility maintenance operations, mostly in biotechs and pharma production sites. 10 of those years I spent carrying a bag as a calibration technician. Today I want to talk about the details of failures of two liquid nitrogen systems in two different fertility clinics in the U.S. that's occurred in the last few weeks. One was in Cleveland, one was in San Francisco. I might say in passing, I've worked on liquid nitrogen systems in the past. I've calibrated them, I've done troubleshooting on them, and I've maintained them too. So when it comes to fertility clinics, there's one first fact that we need to keep in mind. When customers come to a fertility clinic and ask to have their embryos stored, over time they come to think of those embryos as their kids. So the kind of failures we've seen recently are very, very devastating to the customers of the clinic. The clinic wants to avoid this kind of failure at all costs. Okay, so let's start off with a demonstration. I'm going to add some liquid nitrogen to a fertility clinic LN2 tank. Now let's talk about a few attributes of this fluid. It looks like water, but it's not like water. It's extremely cold. Even though it flows like water, it's almost always seen only at one temperature, which is 77 degrees Kelvin. 77 degrees Kelvin is only 77 degrees centigrade above absolute zero. It is really cold. Also, it boils all the time because it's always in contact with substances or materials that are warmer than it is. So it boils easily and rapidly. This puts people at risk because liquid nitrogen boils to gaseous nitrogen, which is tasteless and odorless. However, it will force air and oxygen out of a space. If it's a small confined space, you can be asphyxiated without ever knowing what's happening to you. So beware of these kinds of risks. If you're going to handle liquid nitrogen or be around it, wear a splash guard and goggles, special gloves, and probably an apron. It's dangerous stuff. Another aspect that involves fertility clinics is that liquid nitrogen boils so rapidly that even the best insulated systems on Earth still lose 2% of their volume every single day. That means the fertility clinic tanks are going to have to be serviced 24/7 to maintain the level of nitrogen that they want. Now let's talk about the level itself. Embryos can last for decades if they're stored always in liquid nitrogen. If they're stored nearby the interface between liquid nitrogen and whatever's above it, they're still probably okay. However, if the embryos ever get to a point where they're at ambient conditions in the lab, their viability ends in just a few seconds. So what we see is a classic gradient problem that has to be monitored and understood very clearly, or else you're going to start losing embryos. And as I said before, that's going to be devastating to your customers. You don't want that. Okay, as we go forward with this discussion, I'm going to assume that fertility clinics do not invent, construct, and maintain their own LN2 systems. The easiest way to deal with this for a fertility clinic is to find a specialty gas supplier in your area. Tell them, hey, I'm going to have tanks that I want to hold no less than 55 gallons of liquid nitrogen at all times. What can you do? The supplier should be ready to handle your needs. They will supply you the tanks, all the hardware, and a continuous supply of extra liquid nitrogen to overcome the boiling that I talked about earlier. Here's one of the problems that the supplier is going to face. Here's my liquid nitrogen tank. I'm going to swap this liquid nitrogen and put it in another tank. The boiling rate between the liquid nitrogen in this tank and the liquid nitrogen in this tank is going to be different because the two vessels have different surface areas. This has to be taken into account by the supplier. So they have to fully map and fully validate the container they're going to use to hold their product in and to preserve the embryos. If they don't do it, they're going to put those embryos at risk without even knowing it. One of the problems here is you don't know if the embryo is still viable without looking at it individually under a microscope. So clearly you'd rather be safe than sorry. Okay, let's talk about some of the details from the supplier's point of view. Not only do they have to supply you with the tank, but they also have to supply you with the hardware to go with that tank. In other words, you've got to know at all times what's the temperature in this vessel or what's the level of the liquid nitrogen. That information is provided by sensors. Those sensors can fail, especially because they're being exposed to some extremely cold conditions. So you need to use the right sensors. Elsewhere, I've produced a couple of very short videos that talk about a very cool way to improve the reliability of these kinds of sensors. So check it out down below. I think you'll be fascinated by this idea that I first encountered when I read an article written by a guy named Dan Collins. I really recommend that you read this article. I think you'll like it. In any case, there's other hardware challenges for our supplier. He has to supply a larger tank that allows liquid nitrogen to flow to our tank when it's needed. That's going to have to occur through some sort of valve or control device. Those control devices are vulnerable to the fact that they too are being exposed to an extremely cold substance and need to be able to work reliably under those conditions. Another thing the supplier has to provide is some sort of alarm capability so that if something goes wrong, people are notified immediately rather than, hey, Friday it happened, Monday you come in, you're at a total loss. You don't want that to happen. You need quick alarm response, and that's the responsibility of the supplier. Another thing to take into account is, suppose you're in a city block in Cleveland or San Francisco. Your block loses power. There's no power anywhere in that block. What happens to your system? The supplier should be able to help you figure out what kind of backup do you need to ensure that this function still occurs under any conditions. So what's behind that assurance? Is it just because someone said, yeah, they think it's going to work, or it's actually been tested under the conditions that we see in front of us? The second alternative is the one that you really would prefer. So, I've touched on some of the particularities of the problem of delivering LN2 systems to the customer. I hope I've also touched on a few issues that other facility maintenance guys will recognize as the kinds of things that come up and have to be grappled with every single day. In the meantime, on behalf of my makeup guy Carl and my visiting director from Lancaster, Pennsylvania, thank you very much for your time, and stick around. I'm going to do more videos. Thank you.
That was good.